work for Kyndryl, and today I wanted to talk a bit about Cloud Foundry to Kubernetes migration, more specifically the Google Cloud flavor of Kubernetes, GKE. We've had a lot of interest in our customer base in recent history of wanting to migrate from Cloud Foundry, and of course those familiar with Cloud Foundry are very familiar with it being a platform as a service, really focused on developers and having the unusual simplicity of just being able to push code. So effectively, if you have a source code directory, you point it towards Cloud Foundry and off you go with deploying microservices. It's really completely tailored to the developer. Now we transition, probably with greater acceptance in recent years, to the world of Kubernetes. Slightly different from the Cloud Foundry space in the sense that there's a lot more tailoring that can go on of that platform. It's not simply, I shouldn't say simply, but not solely focused on microservices, as in 12-factor and stateless, but give you much more options in the Kubernetes world to run stateful workloads and daemon sets, and more easily include third-party applications, probably coming as Helm charts, and those could be databases or middleware components, what have you. So slightly different methodology and platform approach in Kubernetes, and I think the flexibility of sort of, we'll call containers as a service with Kubernetes has been sort of trending up these days. So I want to talk today a bit about making that transformation or migration from a legacy Cloud Foundry to a modern cloud-based Kubernetes environment. The first thing to sort of reflect on is what's the difference between Cloud Foundry and Kubernetes. I talked to this a little bit, but if we look at this series of application stacks in front of you, sort of a generic one shows you all the levels in an IaaS platform on the far left. Obviously, in an IaaS, there's some core provided capabilities close to the hardware, even the virtualization level. And above that, it's effectively bring your own application, as well as how do I provide networking and integrate RBAC and authorization and deploy and scale. All those are sort of brought by the user. Cloud Foundry has an opinionated approach to how all these things happen. So effectively, you're just bringing your deployment pipelines, CI/CD pipelines, and the application source itself to the platform, and much of those in-between layers are handled for you. And you have something called BOSH, which is really a lifecycle manager, deployment automation tooling for the Cloud Foundry platform itself. So, and this is highly opinionated. When we say Cloud Foundry is providing those middle layers, there's the Go router that handles routing for you. So it's not easy to plug in some alternate networking or SDN mechanism as an example. And that same sort of philosophy of providing a solution for you in an opinionated manner continues through the whole stack. So counter that is Kubernetes, where some of the core components are going to be, it's obviously container-based, Docker-based, and it's getting deployed obviously on some form of either bare metal or virtualization and an operating system. And then adding on to that, you are providing the code that is in that probably polyglot environment with containers and whatever's running inside of there. There's help in Kubernetes in terms of, can you plug in a software-defined network? What do I use for a CI/CD process? Where do these images get stored and pulled from? So there's, what am I doing for logging and monitoring and metrics? So those things are all sort of added on in our choices with the Kubernetes environment. Now, if I choose to take one of the hyperscaler Kubernetes versions, so either AKS, EKS, or GKE, being Azure, AWS, and Google GCP, respectively, a lot of those integration points are provided for you by the hyperscaler themselves, right? So obviously, we're going to be sitting on top of of their block storage and virtualization layers, and of course that hardware beneath that, and then they're plugging in many cases either an open source SDN within the Kubernetes platform, or using the virtual networking provided by the hyperscaler. And of course, integration. All of these have a solution for logging and monitoring metrics and alerts, and plugging into authorization and RBAC and so on. So a good benefit there of having all that integrated. So the pieces of the Kubernetes stack that are missing are in full, really, in the hyperscaler versions. So getting back to the subject at hand, we're going to talk about how we get to GKE from a legacy Cloud Foundry application. We'll look at some code actually, and give you an approach to move that over to GKE. Before we get into that, just want to sort of lay out the high-level analogy of moving from different components within the Cloud Foundry environment to those in Kubernetes. So if you're familiar with Cloud Foundry, then you know there's this notion of organizations and spaces, and that's kind of how I organize my applications into groups and provide multi-tenancy. I'm going to probably run multiple Cloud Foundry instances, at least if I have paired data centers and I'm looking for disaster recovery, potentially high availability, depending how far apart they are, I'm going to use at least 2 instances. Cloud Foundry itself is usually one large platform that's that's managed by kind of a centralized team, a little counter to what you'd see with Kubernetes, where clusters are most likely tied to parts of an organization, and in even some cases, clusters may be deployed based on application sets and maybe even promotion stages in a delivery cycle. But you do have this analogy between the organizations in Cloud Foundry to namespaces, most often inside a cluster in Kubernetes. So that's a commonly chosen mapping paradigm. And then within organizations, you normally have spaces, and they might be promotion stages of dev, test, pre-prod, prod, etc. And they could be mapped into in some cases namespaces, or just application sets that have labels. So there's some options there, but it's kind of this diagram talks to the overall flavor. One thing that differs between Cloud Foundry and Kubernetes, among other things, is the fact that the notion of a third-party service, whether it's some integration middleware or database, those things are usually accessed through a open services broker on the Cloud Foundry side. So there's an external service that's providing and lifecycle managing that service. Again, it could be just about anything. The way that's often handled in the Kubernetes world, well, in a hyperscaler Kubernetes version like GKE, it could be using the SQL services of Google, right? Something that's picked a database management service on the Google Cloud, like Spanner, and then there's laundry list of options for columnar databases and whatever I choose there. Those things could be just used as services directly and attach those to the Kubernetes cluster, or I could, in fact, in GKE, go and deploy with a Helm chart, a Postgres database or a Kafka instance, right? So a little different mechanism. Those things are not a part of the core Cloud Foundry itself, but are brokered through a service interface. So how do we, or how have we, Kyndryl, move some workloads from Cloud Foundry to Kubernetes, and specifically GKE? Well, we've been a big part of an open source effort, including our partners at IBM and Red Hat in the Conveyor project. So this effectively is a series of projects that, based on your cloud journey path from Cloud Foundry, or frankly any legacy mechanism, and you're wanting to get to Kubernetes, you would effectively look at one of these sub projects within Conveyor, and the choice you would make would be the result of some assessment. So there's actually a tool that helps you called Tackle, and then you can look at what are my 6 R's or 5 R's that are kind of industry standard. I'm going to rehost, replatform, refactor, and based on that path, I'm going to have a different tool and Conveyor sub project that's going to assist me. So here we're going to focus on replatforming, so effectively not changing code, but changing all the surrounding manifest and description files, and how that application is deployed to match the platform of choice, in our end state being GKE. I'm going to take a look at how move to Kube would help us in this case. So move to Kube is going to look at and do some analysis on that legacy environment. So we're talking Cloud Foundry, but it could be other forms of language stack or other legacy types of orchestration engines like a Docker Swarm or even a Docker Compose file. And Move to Kube has analysis engines that effectively review these constructs and maps them into a target environment that's Kubernetes aware. So it's effectively going to build output things like Docker files and YAML manifests that are going to be dictated by Cloud Foundry manifests and build packs and legacy source code, and it's going to create the what needs to be created to deploy those things, even CI/CD pipeline or Helm charts or operators, etc. So how do we use move to Kube? So there's basically 3 commands here, and even in its short form, 2 commands. We're effectively just going to point it at the source directory of the legacy Cloud Foundry application, and it's going to run a plan for us. So if you're familiar with how like Terraform or Ansible works, before I go and do a potentially destructive exercise on my target environment, I often want to see what the results will be in advance and kind of lay out a plan. And that's effectively what plan does for us. If I point it at that source code, it's going to go and look through with some commonly accepted organization, probably a directory per microservices in Cloud Foundry, investigate each of those things, discover what type of source code it is. Is it, am I looking for a POM file to know it's Maven build environment, and then obviously that implies Java. And is it what's the Java runtime associated with it? Is it Spring Boot? Is it plain vanilla Java? And what other language might it be? Right? It could be if I find a package.json file, it's probably Node or JavaScript, and so you get the flavor for how those things would work. It's going to effectively have a series of engines that it applies against the target environment, and based on that, we'll see what it plans to do, right? And I have the kind of freedom to back out some of those engines in the output of the plan stage, and then follow that up with the actual transformation with move to Kube transform. There's another option to sort of make the transformation richer with the output, and that would be to run what we call move to Kube collect. And what this does is, if I'm connected to a Kubernetes environment, I'm also connected to Cloud Foundry, it can examine those runtime environments and see what's deployed, see what the capabilities are. So it's looking at the runtime environment, what kinds of objects are supported in the cluster, what apps are running in the Cloud Foundry instance, and so on, and kind of metadata around all those. And that helps inform the plan stage, and then that finds its way back to the transform stage. And then the big things we see out of there are going to be some deployment files, a CI/CD pipeline built to fit the target state, and then we'll see a case where we examine the output. So let's take a look at a simple application. So it's simple but complex enough to sort of exercise this transformation technology. So it's a simple website ordering uh, uh, application. So I've got a kind of front end that's going to be a simple Nginx front end, and it's running some Node.js and React. And there's a gateway that's effectively the front end that's calling a series of microservices. So one for inventory, one for orders, one for customers. Each of those in turn has a, a database tier that it talks to. And yeah, pretty straightforward stuff, and probably a commonly seen example of microservices orchestration. The way this is shown in actual source code, let's actually take a look at the source directory where this thing lives. So inside of, there's a move to kube directory. I run the plan stage so you can see some of the outputs here. We'll look at that in a minute. But the legacy source code effectively is organized in that common mechanism, which is a directory effectively for every microservice. And if we look at the front end, there's some very familiar, a bunch of JS source code, and you'll notice some React resources here, and a manifest file that obviously tells us how to build this thing. And there's also some deployment scripts here. So in fact, if I look over here, there's a couple. We're actually targeting the IBM Cloud. It was something that it doesn't really matter what Cloud Foundry it is, but you can see here there's a series of CF pushes, so effectively just pointing to the code and then pushing that out to the IBM Cloud Foundry version. In fact, if I jump over to a command line, we can see that we're connected. Let's just check our environment here. So we see that, I'll have to log in here. Let's see what the IBM Cloud Foundry instance looks like that we're running. And so we see it's under my name there, and we have an org and a space set up for us. And if we look at the Cloud Foundry apps, we can just run a CF apps and see what's up and running there. And so this is the result of this script that was run over here, which was just a series of deployments, a CF push effectively in each of those directories representing a microservice. And we could see those all up and running, and they're healthy instances, and they've got a certain memory and disk size allocated. And if you recall our diagram, it was the front end that was the microservice that was actually deployed somewhere publicly. So let's see if we can browse to that thing. And we can. So this is what the UI looks like for front end, and we can see that it's connecting to the gateway, and then obviously providing connectivity to the microservices that are providing the customer info, the orders, and of course products. So the Cloud Foundry side is up and running, and the result of that work, if we go back to that directory hierarchy, the result of the analysis, we ran this move to kube plan and then transform, but the output of plan is this file. And let's just go and open up this with Visual Studio Code, and it's a familiar format. It's effectively just a YAML file that almost looks like a Kubernetes manifest, but we can see it's a plan. It's using the move to kube conveyor API, and what it's done here is it's discovered and created a plan for each of the microservices. So it, first of all, it knows it's Cloud Foundry. It finds the service. So we have customers, front end, gateway, inventory, all the microservices that we mentioned. So it went and navigated through the source tree, and then it found out what type of source code it actually was. So it pulls together information on the paths and the manifest. It found that the Java file for the customer microservice. It's figured out that it's built with Maven. Where's the POM file? What are the configs for Maven? What type of Java model is it? In this case, it's Spring Boot, so it recognizes all that and builds this planning stage. And so there's actually, and you'll see that it does similarly for each of the different microservices. In some cases, they're not Spring Boot. In some cases, they are. But this thing at the bottom goes and has an exhaustive list of the transformers, the engines it uses to do the discovery, right? So it could be Go, or it could be a certain type of Java environment like Liberty. It could be Python code, whatever. And we could tailor this. So this is, again, the output of the plan stage. We could pull out the transformers that we're not interested in because we may have some insight into the source code and may not want to use those. So that's the output of plan. And I would just rerun this now in the transform switch, if you will, and it would go and then actually do the transformation output. And if we come back to the directory structure, it's actually created post-transform a different hierarchy in the source code tree, very similar in terms of organization for the source. So it's gone and created a source directory, and inside of there is again a directory for each of the microservices. But what it's done here is created some other useful things like script files to build images, because after all, we're going to containerize everything now and push them somewhere. And let's take a look at what one of those things looks like. So here's the build script. It effectively it's created a Docker file as part of the transformation, so it understands the manifest of everything that's supposed to go inside of the container that matches a microservice. And we could take a look at those. If we take a look at front end, we can go and open that. And of course, this does not recognize that it's a Docker file, but we'll just take a look. So it knows that's a Node.js base image and builds the Docker file appropriately, install npm and do a build and run. So, and similarly, it's creating the Docker files for each of the other microservices, and then those things can actually get pushed. And some of what was done in the collect stage could populate some of the information that we would use to actually go and push it to a container registry, right? So what's the namespace we're using, or the repo beneath the actual registry. And so I've run this and because it did discover, so if we go back to my command line here, we're connected to GKE. If I just run some kubectl command here, let's say get deployments, we would see that all of these deployments and services have been created also, right? So not just the build information, but if we look under deploy, you'll see a bunch of YAML files that say, okay, here's the service I need. This is the deployment definition. So this is the customer's YAML manifest. So it puts a service in front of this and creates the deployment. We know where the the container image is stored because it did discovery on that. And when it builds it, it's going to put it in this location in GKE in the Google artifact registry for containers. And then of course, when it gets deployed, it's gonna pull from there. So we're getting a kind of full deployment service, and it's creating secrets as needed or config files. So pretty much the whole infrastructure we need to deploy. And so if we come over and look at this thing, so I'm connected to my GKE environment. Well, you saw me run the command line, but those workloads exist here. Everything is healthy, so we see microservices running on the cluster for each of the what's been transformed. If we look at things like the front end, it's going to have an associated load balancer, right? So we've got a Ingress set up here, and we can take a look at that thing. And if I look into that, we're going to see a series of products. There we go. It took a minute to refresh. So, and this now is over on GKE running the results of the transformation. And there was really little we had to change to get this to work. So those images all ended up in the artifact registry. It's been some time since I deployed those, but you get the point. And all of this automated transformation was done for us by Move to Cube. So that's it. Pretty straightforward. Using the tools from Conveyor, Move to Cube, and this is how we can do a lot of rapid analysis on legacy environments like your Cloud Foundry environments, and target new Kubernetes clusters like the one you see running here in GKE. So thanks for your time. Appreciate it, and let us know if we can help. Thanks. Take care.